Hello everyone. Good morning. This is Sowmiya, Assistant Professor of Physics, Arignar College, Arts and Science, Krishnagiri. Today my topic is Hyperbolic Cosine Gaussian beam. First I talk about nano-optics. What is nano-optics? The study of light-matter interaction at the nanoscale, focusing on how light behaves and interacts with objects smaller than its own wavelength, typically in the range of 1 to 100 nanometers, revolving unique optical properties. Energy, localization, and non-linear interaction are key principles influencing the generation of light at nanoscales. Nano-optics operates at dimensions ranging from a few nanometers to several hundred nanometers. Nano-optics involve confining light to tiny space, enabling manipulation and control of light at the nanoscale. At the nanoscale, quantum effects become significant, leading to unique optical phenomena. What is Ricciards and Wolf vector diffraction theory? Vector diffraction theory is a more rigorous approach to understanding wave propagation, particularly in optical systems with high numerical aperture or specific polarization. In systems with high numerical aperture, such as those used in microscopy or optical trapping, the angle of light rays becomes significant, and scalar diffraction theory, which assumes para-axial propagation, is no longer accurate. Vector diffraction theory explicitly accounts for the polarization state of light, which is critical for application involving polarized light or engineered phase profile. What is focusing properties of cylindrical vector beam? The cylindrical vector focusing consists of following properties as listed below: geometry, radially polarization, azimutally polarization. Geometry. Geometry is a branch of mathematics that deals with the study of shapes, size, positions, and dimensions of objects. It involves understanding the properties and relationship of points, lines, angles, planes, and solids. Location in space represented by coordinates x, y, z. Radially polarization. Radially polarized light is a type of polarized light where the electric field vector is oriented in a radial direction, meaning it points outward from the center of the beam or inward toward the center. Radially polarized light has cylindrical symmetry, meaning its properties are the same in all directions around the axis of propagation. The polarization pattern of radially polarized light is characterized by a radial arrangement of electric field vector. Radially polarized light exhibits unique optical properties such as a donut shaped intensity. Azimutally polarization. Azimutally polarized light has circular symmetry, meaning its properties are the same in all directions around the axis of propagations. Azimutally polarized light is used in optical trapping and manipulation of particles. Azimutally polarized light is used in microscopy techniques such as polarization microscopy, device that convert linearly polarized light into azimutally polarized light. Certain laser sources such as azimutally polarized laser can directly produce azimutally polarized light. What is different method for optical trapping? dual beam optical trapping, single beam optical trapping. Dual beam optical trapping. Optical trapping, also known as optical tweezers, is a technique that use light scattering to hold an object in place. Optical trapping is based on a concept outlined by Arthur Oxen in 1986 that later earned him the Nobel Prize in Physics 2018. The fundamental behind optical trapping is that light has movement and can exert physical pressure on objects. Optical trapping can also be used on samples that are smaller than the wavelength of light, 200 nanometer. The main change being that the way the light is scattered is very different. My scattering for larger than 200 nanometer, Rayleigh scattering for smaller than 200 nanometers. Single beam optical trapping uses a tightly focused laser beam to manipulate microscopic objects by transferring momentum from light to the object, creating a 3D stable trap. When light interacts with a particle, it can be scattered, and this scattering represents a change in the light's movement, which in turn exerts a force on the particle. Measuring force acting on a trapped bead caused by liquid flow in microfluidic chamber. Measuring pulling force on a filament attached to the glass surface. Measuring bed cell interaction force. What is principle of focusing hyperbolic cosine Gaussian beam? Focusing azimutally polarized hyperbolic cosine Gaussian beams involves using vector diffraction theory to manipulate the intensity distribution in the focal region. The refers to a types of polarization where the electric field vector oscillates in all directions that rotates around the beam's propagation axis. This beam type is characterized by a hyperbolic cosine function in its radial profile, which differ from the more common Gaussian beam profile. The ability to manipulate focal patterns and create novel focal spots opens up possibilities for application in optical tweezer microscopy and other fields. Conclusion. The azimutally polarized higher order hyperbolic cosine Gaussian investigated theoretically by vector diffraction theory in high numerical aperture lens system. Results show that intensity distribution in focal region can be altered considerably by the topological charge n and decentered parameter beta of hyperbolic cosine Gaussian beam. Many novel focal patterns may occur single focal spots, single focal holes, three focal spots segments. In addition, four focal holes distribution were also calculated and illuminated to show the focal pattern of hyperbolic cosine Gaussian beams through a high numerical aperture lens may find applications in optical data storage and multiple optical trapping. Thank you.